This is our AP review, topic 10, but I have modified this topic for the 2020 exam. Okay, so I'd like to begin by just talking about the series topics that are going to be covered on the 2020 exam. First of all, they are going to cover the geometric series test. Okay, so we'll discuss that. They're going to cover P-series test and the harmonic series. So we'll review what those are. Also the alternating series test. And the last convergence test that they're going to cover is the ratio test. I don't think any of those are too shocking to you. These are probably the four biggest tests used. The only one that is a little surprising that's not here to me is the comparison test, the limit comparison test and the direct comparison test. But those two are not covered on the 2020 exam. Okay. Also, as part of the series, they've included here finding a Taylor power series. How to find a Taylor series. Okay. So I split this up into two units. One was just all the convergence and divergence tests, and the other was all of the power series stuff. So the only topic from our power series unit is just finding a Taylor series. So we will discuss that as well in this little preview to this topic. Okay, first of all, for the geometric series test, if you'll allow me to abbreviate some of these things so I don't have to write it all out. Geometric series test. Okay, first of all, a geometric series can be written in the form, got your sum, and then some constant times r to the n. Okay, some constant times r to the n. So every geometric series can be written in that form. Okay, so the test is if the absolute value of r is less than 1, then the series converges. Okay, if the absolute value of r is greater or equal to 1, then that series diverges. And remember, a is just a constant here. Okay. Also, one more thing about the geometric series. If it does converge, it converges to a over 1 minus r, where a is the first term in the series. Okay? So keep that in mind. So this would be like when n was going from 0 to infinity here, and then a would be the first term. Okay? All right, so that should be really straightforward. We had a lot of problems on that, on geometric series throughout that unit. All right, next up, the P-series. Okay, so first of all, let's say what a P-series is. So a P-series can be written in the form, got your sum, and then it's some number. I can put I'm just going to put a 1 up here, but know that if there's like a 5 or anything, just like here, if there's this a can be taken totally outside of your sum, this can be any number, right? But it can be written in this form. 1 over n to the p, all right? N is your N is your counter here. It can start really anywhere we want it to start, but any value that makes this all the terms real. But anyway, P is just a number. P is a number. Okay, so P is a constant. Maybe it's a 2 or a 5 or a pi or a 0.5 or anything like that. So P is your constant. All right, and the test says if P is greater than 1, if P is greater than 1, then that series converges. If P is less than or equal to 1, then your series diverges. So almost the opposite of a geometric series as far as R and P. But remember, R here is up in the numerator. R is a number, right? Here, P will make the denominator bigger or smaller, so or large or small in relation to 1 over n. Anyway, so it kind of makes sense there. The bigger the denominator, the more likely it is to converge, right? Whereas if you have a smaller denominator, more likely it is to diverge. Okay. Unlike the geometric series test, we do not know what this P series converges to. We don't have a little formula that says what it converges to. Okay. Number 3, our alternating series test. I'm going to abbreviate that. Alternating as alt. Okay. So an alternating series test. First of all, an alternating series has terms which are alternating in sign, which are alternating in sign. Okay? Alternating series test is only a test for convergence. Okay? The only thing we use it for is convergence. Okay? And here's what makes an alternating series converge. All right? If a series has terms, my phone thought I was talking to it. Okay, if a series has terms which are alternating in sign, and decreasing in magnitude, to 0. In other words, and has a limit of 0. So terms are alternating in sign and decreasing in magnitude to 0. If those 3 things are true, then the series converges by alternating series test. Okay? So we can write this in a couple of different ways. Alternating in sign is very obvious. You can see it just from looking at your series. If it has a -1 to some n power, quite likely it's going to be alternating. So that's easy to see. Alternating is easy to see. Decreasing in magnitude is a little bit more complicated to see, but in general, decreasing in magnitude means that the magnitude of the next term, the n+1 term, has to be less than the magnitude of the term in front of it. So the 5th term is less than the 4th term. The 6th term is less than the 5th term, and so forth. And this would be for all n in your series. Limit of 0 is easy. That's just the limit as n approaches infinity of your a sub n, your argument of your sum, must be 0. So that's, all three of those must be true. Okay? All right. If you have an alternating series, but it's not decreasing in magnitude to 0. So let me jot that down. If an alternating series is not decreasing in magnitude to 0, then the series diverges. But it does not diverge by alternating series test. It diverges by nth term test. Okay? Now, on the 2020 exam, the nth term test is not one of the ones that they say they're going to cover. Okay? So I'm thinking that you don't have to worry about that too much, but it's, hey, this is a good little review. So there you go. All right. Lastly, the last convergence test that they are going to cover is the ratio test. Okay, and for the ratio test, let's say that we have this series. We're testing the convergence of this series. Okay, testing the convergence of that series. So if the limit as n approaches infinity, this is your setup for the ratio test. Limit as n approaches infinity, you need to put your n plus 1 term over your nth term. Okay? And if that ratio, that's why they call it the ratio test, if the limit of that ratio is less than 1, then that series converges. Okay? If that limit is greater than 1, then the series diverges. Okay? And if that limit is equal to 1, then we have to go use a different test. Because the ratio test is inconclusive. Okay? So these both converge or diverge by ratio test. If the limit is equal to 1, go use another test. All right. One last thing. So that was a quick review on the 4 convergence and divergence tests that will be covered on this 2020 exam. Let's go ahead and do a real quick overview of Taylor series. I'm just going to give you how to find that. So this is number 5 on there. For a Taylor series, the Taylor series for any function, f of x, centered at x equals c, is given by, so this is how you find a Taylor series for any function centered at x is equal to c. C is a constant, okay? It is, we begin with just f of c. So whatever f of x is, you put that number in for x, you're going to get a number. F of c is just a number, and that's your constant term of the power series. Plus, now we go to the next term, and the next term has, it's composed of a derivative, a factorial, and a power of x. All right? So we're going to start with the first derivative. So this is the first derivative at c, the first derivative of f at c. We divide by 1 factorial and we multiply by x minus that center value to the first power. And then we go to the next term. The second derivative divided by 2 factorial times x minus c squared. Next term, the third derivative over 3 factorial times x minus c cubed, and so on and so forth. So it'll be the nth derivative at c divided by n factorial times x minus c to the n, and I'm going to squeeze in a last little plus dot 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 to continue that series. I should have started way over here. Okay, so just remember the little format for these. Second derivative, 2 factorial, power of 2, right? So those all match every time. And we begin with the constant term. So don't forget the constant term. Many, many times they ask you to write the first 4 non-zero terms and the general term. Okay? All right, so that's just a little quick review. Now let's go to your little packet, the worksheet packet that I made up for you. And in this, I did revise it. So what I did was I took recent tests, recent AP exams, but I only included the parts that were applicable to what you guys will need for the 2020 exam. Okay, so in the 2019 and the 2018, the way those tests were, I don't think that any of the parts were applicable to just finding a Taylor polynomial. Okay, so in 2017, that was the first one going back that it was applicable. So let's take a look at this. I'm going to do 2017 with you, and then I'll leave you the other ones to do. All right, so it says a function f has derivatives of all orders for x between -1 and 1. The derivatives of f satisfy the conditions above. So above it says f of 0 is 0, f prime of 0 is 1, and remember that this is the notation for future derivatives, for derivatives. So f, the n plus 1 derivative of f at 0 is given by this equation. Okay? The Maclaurin series for f converges to f of x for those values of x. Okay, so they're giving you the interval of convergence for f there. All right. Part A, but this was part A from 2017, and it's the only one that's applicable. It says show that the first 4 non-zero terms of the Maclaurin series for f, remember Maclaurin is when c equals 0, are this. So they're telling you this is the Maclaurin series, okay? Now you have to verify it. You have to show that that is. So they're giving you the answer. Now you just have to show the work that would get that answer for the Maclaurin series. And then we also have to write the general term. All right? So for any Taylor series, we start with f at the center value. F at the center value. Well, since it's a Maclaurin series, our center is 0. So f of 0 equals. We always start there. And in this problem, they gave it to us. It's 0. Okay? Now, unfortunately, we need the first 4 non-zero terms, so that doesn't count as one of those 4 non-zero terms. So we need to go, we're going to need 4 derivatives here because this one didn't count for one of our 4 terms. Okay, next up, first derivative. We need the first derivative at 0. If they gave me the function for f, I would actually find that derivative, right, and then plug in 0. But here, this is a different type of problem, so it's a different delivery of the problem. They just gave us that derivative, right? Just gave it to us. So my first term in the Maclaurin series will be 1 over 1 factorial times x minus 0 to the first power. So once you get that first derivative, you could go over here and write the first term. I think what I'm going to do is get all of my derivatives first that I'm going to need. Okay. All right, now we need the second derivative at 0. We need the second derivative at 0. I have to come and use this little formula. Well, the second derivative in this formula, it would be that formula when n is equal to 1, right? Because when n is 1 here, the derivative is the second derivative. So I need n to be 1 for the second derivative. So it will equal negative 1 times the nth derivative. So remember, n is 1, so the first derivative at 0. This is negative 1 times the first derivative at 0, which is right here. That's times 1. So the second derivative at 0 is negative 1. Okay? On to the third derivative. So here's our formula. The third derivative is when n is 2. So I'm going to put the 2 in for n over here. So I'll have negative 2 times the second derivative at 0. That's negative 2 times the second derivative at 0 is my negative 1 here. So this is equal to 2. I need one more because I need 4 non-zeros, right? So the fourth derivative at 0 will be when n is 3. So it'll be negative 3 times the third derivative at 0. So negative 3 times 2, and that is negative 6. All right. Now that we have all these derivatives, I can go and write the Maclaurin series. Okay, so Maclaurin series for f would be this. So I would start with 0, but because that's just 0, I'm going to go to my 1 here. So it'll be 1 over 1 factorial times x minus 0 to the first power. Plus, okay, next derivative. The next derivative is a negative 1. The term is this is all the second derivative, 2 factorial, second power, so 2 factorial, x to the 2. Next derivative, this is the third derivative, so 2 over 3 factorial, x cubed. And then the last of the 4 non-zero terms would be plus negative 6 over 4 factorial x to the 4th plus dot dot dot. I'm not going to write the general term quite yet because it's going to be easier to write it once I simplify this. So let's do simplify it, and we know what this is going to simplify to because they gave it to us. If we did this right, it will simplify to this. So yes, this is just x, okay, minus, this is 1/2, right, x squared. 2 factorial is just 2, so 1 over 2, x squared, which is the same as x squared over 2. I want to write it like they tell me to write it over here. Plus, okay, this 3 factorial will reduce with the 2 on top. The 2's will cancel out, and you'll be just left with 3 on the bottom. So this will be x cubed over 3 minus, okay, the 6 will be the 3 times 2 in the 4 factorial, and I'm left with 4 on the bottom, plus dot dot dot. So I verified those are the first 4 terms, and now the general term here, it's alternating in sign, so negative 1. If I do start n at 0, then I want my first term to be positive, and so at negative 1 to the 0 would be positive 1, so that would work. So if I start n at 0, that will work, and then I would need x to the, I want my first term to be a 1, so this would need to be an n plus 1. And then every term means just n here, not 2n or 3n or anything. Divided by, and the power is the same as the denominator, so this would just be n plus 1. And that would be fine and perfect for an answer. We could have an alternate to that general term would be, what if we started n at 1? If we started n at 1, then I don't want to just put an n here, because if I start n at 1, this would be a negative, and I want that first term to be a positive. So I would need to do it like a plus 1, like that. That would be great. Okay. Then I could put x to the just n, if we're starting n at 1, divided by just n, and that would be the same thing. Both of those would be correct for the general term. Okay? You could also start n at 2 if you want, but really stick to 0 or 1. They're the most logical here. Okay, and that's the Maclaurin series for that. That would be the right answer. The way they scored this particular problem, they gave 1 point for finding f double prime of 0, f triple prime of 0, and the fourth derivative at 0. So finding these derivatives was worth a point. And then 1 point for verifying the terms. So that would be the first 4 terms. And then 1 point for the general term. So this part back in 2017 was worth 3 points. Okay. All right. Next up, I'm going to leave those for you to do. Oh, I take that back. In 2019, you could have done the part A, so you'll get a chance to do the one from 2019. That's good. I guess it was 2018 that I had to get rid of. Okay. All right, and then these are just some questions on here, and you can read it on your paper. These are just like to review. I tried to make as many of these free response type questions, but it's not like one big free response question. It's just several little ones, all right, just to review and to remind you how all of these worked, okay? So I'm just going to do a few of these with you, beginning with number 1. It says function f has a Maclaurin series given by this. This is the Maclaurin series. What is f of x? So when you're determining what f of x is, you guys, look at the denominators. Avoid choosing an f of x based on the numerator at the beginning, okay? Look at the denominator. The factorials are hard to mess with, so just look at the denominators. These are all the odd factorials, and we know those are the ones for sine. I guess I could have reviewed that with you as well. This might be a good time. Remember, sine x is all of the odds, right? So x, it's alternating in sign, minus x cubed over 3 factorial, plus x to the 5th over 5 factorial, etc. All of the odds, okay? Cosine is all of the evens. So 1 minus x squared over 2 factorial, plus x to the 4th over 4 factorial. I think you guys probably remember this. It was not that long ago. I did a minus here, plus there, alternating in sign. Okay, it wasn't that long ago that we did this. And then you also need to know the one for e to the x. E to the x is all of them and all positive, right? Pretty sure you still need to do those, okay? Oh my goodness. Okay. You get the idea. All right. So here I know we need sine because of the denominators. This might be a little confusing. If you looked at the numerators, you might think, oh my gosh, those are all the evens. Maybe this is a cosine. You'd be going down the wrong path, because there won't be a way to change cosine's denominators. It's easy to change a numerator. It's less easy to change a denominator. So go to your denominators. That will tell you what to focus on. So I'm going to write the series for sine. sine sine looks like this, okay? And my denominators are the same here now. Now I look at my numerators and I ask myself, how can I change my numerators to what I want? Well, if you look at the 7 factorial here, I've got an x to the 7th, I need an x to the 8th, I just need to multiply by x, right? The signs are all the same, so I don't need to do anything with that. I just need to multiply by an x, and to multiply by an x, I would just come down here and multiply both sides by x. And if I do, I'll have an x squared minus x to the 4th over 3 factorial plus x to the 6th over 5 factorial minus that x to the 8th over 7 factorial, and on and on. And now my series both match exactly, so f of x must be x sine x. When I first gave this to you guys, I had multiple choices, and I just got rid of the multiple choices so that you would like work it out and write your answer like you would need to if this was a part of an FRQ. That was my thought on these. If it's part of an FRQ, I want you to be able to show your work and do it to their satisfaction. Okay, next up I have that I'm going to do number 4 with you. I'm not sure why I chose this, but oh well. They say let f of x be this series, and they want you to evaluate f at 2 pi over 3. So f at 2 pi over 3, I'm replacing x with 2 pi over 3. So this will be the series of cosine of 2 pi over 3 to the 3n. Okay, which is, I know what cosine of 2 pi over 3 is. Cosine of 2 pi over 3 is a negative 1/2, right? Now, what you don't want to do here is make the mistake of saying, oh, this is geometric and r is negative 1/2. Tempting to do that, but you would be wrong because r is not negative 1/2 here. If we wrote out the terms, you would see you are not multiplying by negative 1/2 each time, okay? It's because of this 3 here. That 3 here. Remember that a geometric series, where were my notes here? Oh, a geometric series can be written in this form, right? R to the n, not r to the 3n, r to the n. So let's change this. This would be negative 1/2 cubed to the n, right? When you have a power to a power, you multiply the powers. So this is negative 1/8 to the n. So r is not negative 1/2, r is negative 1/8. So geo, r is negative 1/8. Our first term of the series, if you put 1 in for n, our first term of the series is also negative 1/8 in this case. So the sum, this series, which is the sum, would be a over 1 minus a negative 1/8. Great thing about FRQ, say stop. If they ask you to verify something or whatever, then you would need to simplify quite likely. So multiply top and bottom by a negative 8. I'm sorry, top and bottom by 8. And then, I knew I was saying that wrong. So this would be negative 1, that's a plus, sorry. Negative 1/9, like that. Okay, I knew that didn't look right. Okay, next up, what do I have us doing? Number 7. Let's take a look at number 7 here. It says the function f has a Taylor series about x equals 2 that converges to f of x for all x in the interval of convergence. You remember that kind of terminology. The nth derivative of f is given by this equation, okay, for n greater than or equal to 1. and f of 2 is 1. Write the first 4 terms and the general term of the Taylor series for f about x equals 2. So, it's another one. We begin with the constant term, right? The constant term is just 1. So the first term is 1, and that's our first term. Okay. I could go over here and write, but I think I'm going to wait until the end, until after I get my derivatives. All right, and then we go to the first derivative at 2, right? I need it at 2. Again, if they gave me a function for f rather than this formula for finding a derivative, I would find the derivative myself and then plug in 2 for x. But since they gave me this formula, I need to use it. So the first derivative is when n is 1 in this case. So it's going to be 2 factorial over 3 to the first, right? And that's exactly how I'm going to write it, 3 to the first. The second derivative at 2 will be when n is 2. So n is 2, so that will be a 3 factorial on top, and 3 to the 2 on the bottom. Write it like that. Avoid actually multiplying it out. You might lose your pattern. The third derivative is when n is 3. So we'll have 4 factorial over 3 to the third. And these will give me 4 non-zero terms. It just said 4 terms, but these will give me 4 terms. So I'm going to go and write the series now. So Taylor series for f about x equals 2. That's my c value, right? So I need to remember to put x minus 2, x minus 2, x minus 2, not just x, right? Okay, first term is 1. Okay, second term, we'll have this derivative. That's the derivative. And then we would divide that derivative by 1 factorial. Well, dividing by 1 is the same thing as multiplying by 1 over 1, so I'm going to write that down here with the 3 to the first. And then here comes my x term, my x expression, x minus c, c is 2, to the first. First derivative, first factorial, x to the first. Now for the second derivative term. 3 factorial over 3 squared divided by 2 factorial, which is the same as multiplying by 1 over 2 factorial, times x minus c to the second power. On to the third derivative term, 4 factorial over 3 cubed times 3 factorial, x minus 2 cubed. Okay, plus dot dot dot. And again, I know I need to do the general term, but I usually do that after I simplify. It makes writing the general term easier. And I know this is going to simplify because of these factorials on top and bottom. They're going to reduce. So let's do that. 2 factorial divided by 1 factorial is 2 on top. Okay? You don't have to put the 1 powers there, but you can if you want to. 3 factorial divided by 2 factorial it leaves a 3 on top. Definitely do not reduce those though, because again, you'll lose that pattern. Not that it's wrong to reduce it, it will make it harder for you to see the general term if you reduce that. 4 factorial divided by 3 factorial leaves you a 4 on top. Okay, and now here comes our general term. It's not alternating, so we don't need the -1. If I start n at 0 here, it would be like I have 1, 2, 3, 4, but if I start n at 0, my first term needs to be that that 1. So the first term would be n plus 1, right? N plus 1 if I start n at 0. And then I have the x minus 2 to the n, because 1, 2, 3 for the powers on that. And the first term would indeed be 0, so that first term would be a 1 over there on that piece, divided by 3 to the n again. And that's it. So I'm not sure how they would score this, but I have seen them score it this way. 1 point for the first 2 terms, 1 point for the third and fourth terms, and 1 point for the general term. In general, that's how they score things like that. Okay? Next up, one that I want to do with you is number 15. So let's take a look at number 15. It says, this was a multiple choice question. I was not going to put it on here, but I thought, you know what, it's good thinking questions. Some of these are good thinking. So even though it's not FRQ, I can see them somehow writing this in an FRQ form, and since it's a good thinking question, I wanted to go ahead and include it. All right? All right, let's take a look at it. They give us that this series converges. The series converges, and they give us that every term is positive in the series. And then they say, if that's true, then which of the following must be true? Number 1, in A, when I see this, you guys, I see the ratio test. This is the exact setup for the ratio test. If you look back at our notes for the ratio test here that I said, that is the ratio. That's for the ratio test. That is the ratio test. So this says that the limit is 0. Well, the ratio test converges when the limit is less than 1, not necessarily 0. So this does not have to be true. It could be true, but it doesn't have to be true. That limit could be 1/2 and it would converge. So not this one, because of the ratio test. The ratio test says less than 1, not equal to 1. Okay? In B, it says that the magnitude of every term is less than 1 for all n. The magnitude of every term is less than 1. That's saying that for this to converge, we can never have a term that's bigger than 1. And that's just, there's nothing true about that at all. That doesn't really make sense. We have lots of series that converge and their first term is bigger than 1. So, and the first term is definitely a term, so I would say a big no on that one. That's just kind of silly. Okay? All right. In part C, it says, if this converges, then this n times a sub n must diverge. Well, multiplying by n certainly would make this bigger, right? Would it always make it big enough so that that would diverge if that converged? So on this one, I'm kind of thinking, you know what? Let me try to think of one where it's not true. So I'm thinking of this sum, 1 over like n to the 5th. That converges. So if I say that, excuse me, 1 over n to the 5th is my a sub n, then for this to be true, then that would mean that n times 1 over n to the 5th must diverge. And we know that that's not true, because n times 1 over n to the 5th is 1 over n to the 4th, and that's another converging p-series, right? Both of these are converging p-series. So this is false as well. We've ruled out everything else, so this has to be true. And if you look at it, they're saying, okay, the series for a sub n converges. So what would happen if you had the series of a sub n divided by n? Well, this definitely would converge because dividing this by n makes it even smaller, right? This series, every term in this series would be greater than or less than or equal to every term in that series. And that's getting to the direct comparison test, but it does also, it just makes sense that this is less than a known converging series, and less than a converging converges. So yes, this would be true. You guys probably got that way faster than that, and I hope you did, and that's all good. Okay, I only had a couple more to do with you guys. What is the coefficient of x cubed in this Taylor series, in the Taylor series for this function? Well, if I'm only looking for the x cubed coefficient, I need to get the third derivative at 0. They tell me the c value at 0. I need to divide it by 3 factorial, and that would be the coefficient of the x cubed term, right? Because that's where that goes. So this is the coefficient, so that's what I need. So f of x, I'm going to let this be f of x. F of x is equal to this function. I'm going to rewrite it and make it in a form where it's real easy to take derivatives, because I got to get to the third derivative. So I'm going to rewrite this as 1 plus x to the negative 2, and then I can whip out a few derivatives here. Okay, the first derivative would be negative 2, 1 plus x to the negative 3, times the derivative of the inside, but the derivative of the inside is just 1. Then I go to the second derivative, and the second derivative will be chain rule again, so 6, 1 plus x to the negative 4, derivative of the inside is still 1. And now my third derivative will be negative 24, 1 plus x to the negative 5, again derivative of the inside is 1. And now f triple prime at 0, our center value, is 1 plus 0 is just 1, to the negative 5 is just 1, so this is just negative 24. And so the coefficient of x cubed is the third derivative divided by 3 factorial. And free response, safe stop. If they wanted to verify or something, 3 factorial is 6, so this would be a negative 4. Again, this was a multiple choice question, and I just took away the multiple choices. Okay. I gave you a few little questions on just you use the test, the appropriate test, state the conditions, state the test. If it's a P series, say what P is. If it's a geometric series, say what R is. Okay. Say the test. So, whatever R is the absolute value of R less than 1, or is the absolute value of R greater or equal to 1? Things like that. Use the test and show it. Remember, this is an FRQ, so you need to go ahead and do the test, right? Okay, I have one last one that I'd like to talk through with you, and that is number 28. Okay. In 28, it says, suppose that this is true. Okay, so this tells me that, like, the 5th term is bigger than the 4th term, and the 17th term is greater than the 16th term. And they're all positive because everything is greater than 0. So this tells me that the series for just a sub n is increasing, not decreasing. So I know already that this series would definitely diverge because it's increasing all the time, right? And then in addition to that, they tell me that the limit of terms is going to infinity for all n. Okay? Which of the following statements about this series is true? Well, this is not just a sub n. This is -1 to the n over a sub n, right? So all of a sudden here's an alternating series where we're dividing by a sub n, okay? And I'm looking at the choices. Diverges by alternating series test, converges by alternating series test, diverges by nth term test, we don't know. So it's clear to me here, I'm looking at the alternating series test. So for an alternating series, we need it to be alternating, and it is. So the series is alternating. Okay, alternating, yes. The series is alternating. The next thing we need is for the series to have a limit of 0, right? So that's kind of the first, alternating is kind of the first step. We need for the limit to be 0. Well, as n goes to infinity, is 1 over a sub n, is that 0? Yes, it is, because the limit of just a sub n, that's going to infinity, so this whole thing must be going to 0 because we're dividing by an unbounded number, right? So yes, check, it is equal to 0. And then the last thing we need for the terms to be decreasing. How do we know the terms are decreasing? Because of this, okay? The n plus 1 term is always bigger than the nth term. So 1 over a sub n must be less than or equal to 1 over a sub n. Okay, so decreasing. Check. So alternating series checks out, converges by alternating series test. Okay, and I know that that's a big old multiple choice question, but it's one of those questions that it involves some thought, and I can see them making it somehow into an FRQ type of question. Okay, that's all I have for you. So try doing these yourself, and see how you do on it. And let me know what questions you have.